Hi, everyone. My name is Lu. I am a software engineer in the MediaPipe team at Google. Today, I'd like to share with you a new product offering from MediaPipe that makes it super easy to train and deploy advanced on-device ML solutions across different platforms. So what is on-device ML? On-device ML is a subfield of machine learning that develops, builds, and deploys ML for edge devices. This includes, but not limited to, mobile, web, desktop, etc. It offers several advantages over the conventional ML that runs on data centers. First, it has low latency. Fast on-device ML unlocks new use cases such as real-time video object tracking. There is no round trip to the server, hence no wait for a result to come back. The second advantage is offline availability. You can use a feature even when there's no internet connection. The third advantage is protecting user privacy. With on-device ML, you don't need to send sensitive user data to server-side for processing. On-device ML is integrated into many of the products that you use every day. Let me show you some examples. Background blur and replace is a feature in Google Meet that I believe many of you should be familiar with. It leverages MediaPipe and runs an efficient on-device segmentation model via the real-time in-browser ML pipeline. Another example is a camera and photos app. On Pixel, photos on blurs faces, reduce noise, and fixes distortions using cutting-edge generative models running on a TPU-optimized pipeline. As you can see in these examples, on-device ML is very useful. However, creating and productionizing on-device ML solutions has not been easy. At a high level, a production-grade ML solution requires on-device models and ML pipeline. Creating production-ready on-device ML models is known to be very difficult. These models need to run on-device with limited computational resources compared to server-side inferencing data centers. So you will need to spend a tremendous amount of effort to optimize your models, making them small and fast, and achieving good prediction quality. On top of the ML models, you also need to build a pipeline to connect them to the rest of your app and streamline the data process, which is equally challenging. Many use cases require a complex inference graph with multiple models, lots of domain-specific pre- and post-processing, and control flows. Achieving high performance is another big challenge sometimes, as the end-to-end holistic acceleration, especially for heterogeneous pipelines, is a huge multi-phase problem. You may also encounter problems when deploying your solutions across platforms onto Android, iOS, web, desktop, bare metal, or IoT devices. As a result, developing on-device ML solutions becomes a mammoth project that requires tons of engineering work. Now, what if we were to tell you that we can simplify how to create and deploy advanced custom on-device ML solutions? Today, I'm very excited to share what we're working on for you. I'd like to introduce MediaPipe Tasks, MediaPipe Model Maker, and MediaPipe Studio, the new on-device products as part of the Tensor project. MediaPipe Tasks is a low-code API to create and deploy advanced custom ML solutions. This library encapsulates all of the complex logic of building an on-device ML pipeline, end-to-end acceleration, and cross-platform deployment on Android, iOS, web, desktop, and IoT. We also provide innovative models that are optimized for on-device so that you can integrate these solutions into your applications with just a few lines of code. MediaPipe Model Maker is a low-code API that lets you customize your solutions with your own data. It is a Python library that lets you choose a solution, such as pen gesture recognition and customize it with your own dataset with only a few lines of code. To make the deployment workflow more effective for you and even enable non-programmers, MediaPipe Studio is a no-code editor that allows you to customize advanced on-device ML models and pipelines across platforms. Our solutions are organized by ML use cases across different domains, such as NLP, vision, audio, and more. We prioritize our solutions based on popular demand, so they include object detection, pose estimation, body and hand gesture recognition, and many more. Now, I'm delighted to announce that the new MediaPipe products, tasks, and Model Maker have become available today as an early preview, supporting 5 tasks, including image classification, object detection, hand landmarks detection, gesture recognition, and text classification. We're actively adding new tasks, and our goal is to have about 20 tasks supported by the end of 2023. You will soon be able to experience the live effect of MediaPipe in MediaPipe Studio in the next couple of days. More powerful features to customize your models and pipeline will come along next year. Please check out our website at developers.google.com/MediaPipe to learn more about how you can leverage MediaPipe in your apps. Next, let me show you an end-to-end workflow of using MediaPipe for hand gesture recognition task, so that you see how easy it is to create custom on-device ML solutions using MediaPipe. All of our tasks comes with a pre-trained model that you can use right away. For the hand gesture recognizer, our off-the-shelf solution can take an image as input and recognize 7 different hand gestures. You can try a live demo of the solution in MediaPipe Studio. As you can see, it can recognize different hand gestures like sum up, sum down, and victory. While seemingly simple, the pipeline is actually quite complex. Imagine chaining together pre-processing, model inference, and post-processing for 4 different models, like palm detection, hand landmark detection, hand landmark embedding, and hand gesture classification. Also consider end-to-end pipeline and model and hardware optimization, let alone cross-platform deployment. MediaPipe Task and Model Maker take care of all this for you under the hood. Next, let me show you how to create and customize gesture recognition using MediaPipe. You can integrate the solution into your Android app using MediaPipe Tasks in just 3 steps. Here's the Android code, but it works similarly for web, Python, and iOS. So you start by initializing a gesture recognizer with a pre-trained model. Then you create an MP image object with your input image. And finally, you call the recognize function with input image and get back the recognition result. The recognize function returns you a list of gesture objects, each representing a potential type of gesture found in the image. You can get other information such as hand landmarks and handedness from the result too. I just showed you how to integrate the solution into an Android app. But as a reminder, MediaPipe Tasks also supports other platforms, such as web, desktop, and IoT devices. And iOS is coming soon. Integrating MediaPipe Tasks into other supported platforms is just as easy as what you saw for Android. And if you want to detect hand gestures that are not recognized by the off-the-shelf solution, you can bring your own training data and train a custom model using MediaPipe Model Maker. For example, if you want to build an app to play rock, paper, scissors. You can start with collecting a training data set with hands showing rock, paper, and scissors. Once you have the data set, use Model Maker to train your custom model. To begin, import the gesture recognizer, load your data set, and train your custom model. That's it. Afterwards, you may run evolve on your testing data. And lastly, export your model. After you have your custom model, you can upload the model to MediaPipe Studio to visualize it right away. You can see that the model can now recognize rock, paper, and scissors gestures. Deploying the new custom model on Android is very easy. You just need to replace the CAN model with a new model that you've just created using Model Maker. The rest of the code remains the same. To help you put all the pieces together, we create a collab. I'll walk you through it step by step, and hopefully you'll get a custom gesture recognition solutions within 20 minutes. Here's a link of the collab. Google/mp-gesture-collab. Let's move to the collab. In the collab, we'll practice the 3 topics together. First, try out the off-the-shelf solutions in MediaPipe Studio. Second, integrate the solution into your application using MediaPipe tasks. And third, customize the solution using MediaPipe Model Maker. Let's get started. Open up the link of the studio, and you can try out the gesture right away, like sum up, sum down, and victory. Remember that we have more advanced parameters for you to config, and you can see more details of them from the documentation. You can also try out our more demos in MediaPipe Studio, and as I mentioned, more demos are coming soon. Next, let's use the off-the-shelf solution in Python with MediaPipe tasks. To get started, you need to install this MediaPipe pip package. And as I mentioned, MediaPipe tasks does not pack with any default models because we support custom models. So you will need to download this off-the-shelf gesture recognizer model bundle to get started. We also prepared a test image for you to try out. And if you want to take a photo with your own webcam, you can skip to the next code step. Let's capture our own testing images. Okay. Now we have a victory sign image. Let's see if MediaPipe task can recognize it correctly. This code snippet contains the code to run MediaPipe tasks. It first imports the necessary modules from MediaPipe tasks, and then create a gesture recognizer object using the model bundle that you just downloaded. And then it creates this MP image object using the images we just taken using the webcam, and then runs gesture recognition and display the most likely gesture. Let's run it. See, the gesture recognized is as victory and with a confidence score of 0.86. That's it. It's very easy to use MediaPipe, isn't it? Next, let me show you how to use the off-the-shelf solution on web with MediaPipe tasks. For this section, we prepared a sample web app on CodePen where we already created some UI elements for you. Let's follow the steps below to add MediaPipe tasks to this sample app. Let's open up the sample app together. To make it easier to add it, you can select Maximize JavaScript Editor. In this collab, we prepared it into 3 steps. The first to do is to add this code snippet, which loads the gesture recognizer class from the MediaPipe SDK. Let's copy this code snippet and paste it into the to-do one in this collab. The second step is to add this code snippet to initialize a gesture recognizer with MediaPipe's off-the-shelf model bundle. Be sure to configure your model bundle correctly through this model as a pass option. Let's copy this code snippet. The third to do is to add this code snippet that takes a frame from the webcam and runs gesture recognition on them and visualize the result. Let's copy the code snippet too. The third to do is at the bottom of this collab. Just paste your code there. Now we're done. Let's try it out. Enable webcam. Sum up, sum done, victory. All look great. So now you know how to integrate the off-the-shelf solution from MediaPipe tasks. Let me show you how to customize your solution using MediaPipe Model Maker. As I mentioned, we can build this rock, paper, scissors game using MediaPipe Model Maker. We already captured a few hundred of images of rock, paper, and scissors gestures. So let's get started from downloading them first. I've already downloaded them, so no need to do that again. In this data set, you'll find there's a directory labeled as none. This directory contains images with gestures other than rock, paper, and scissors. We capture those images to enable the model to recognize invalid gestures that we don't want to incorrectly classify as easy, rock, and paper, or scissors. It's very important to add this non-image category so that your model knows what not to recognize. Let's take a look what is inside this data set. Here are a few examples of each category. Rock gesture, the paper gesture, the scissor gesture, and the non-gesture. To make your model accurate, make sure you collect data with all different positions and angles of your gesture. Next, let's install this MediaPipe Model Maker library, and we'll train a custom model using it. Again, I've already installed Model Maker, so let's proceed. You train a custom gesture model maker model. Start by import the necessary modules from Model Maker. And then load the rock, paper, scissors image data. You can also split the data into training, validation, and testing data set. This step takes a minute or two because we also do image preprocessing, like extract the hand landmark of all the images in the step. Now it's done. Next step is to train the model. Model training is very fast. Takes about less than 30 seconds to train on top of around 500 of images. Here, we use the default hyperparameters, but you can always tune your own hyperparameters according to the documentation. Feel free to visit our website and see what are all those options to twist them. Let's check out the model accuracy. So we can see that the model accuracy is around about 80% for both the training and validation data set, which looks great. Therefore, let's proceed with testing it on the testing data that model hasn't seen before. You can see the testing accuracy is also around 80%, which is quite good. Remember that you can always tune your own hyperparameters to make your model more accurate. Once you are happy with the quality, you can export the model to your local disk. Then, let's go to the MediaPipe Studio and try out the custom model you just created using Model Maker. You start by loading your custom model into MediaPipe Studio. Now the model can recognize rock, paper, and scissors. You can also integrate your custom solution in Python using MediaPipe tasks. So let's verify the input image that we just captured. This is a victory sign image that I captured for the default off-the-shelf solution. Now create a gesture recognizer using the rock, paper, scissors model bundle and recognize the gesture in this image. The code snippet looks very similar, except in this step, you want to replace your default model with this rock, paper, scissors model that we just created using Model Maker. Now, instead of classify these images as a victory sign, the model recognizes it as a scissors gesture. As I promised, we're doing this to build this custom rock, paper, scissors game app. To help you understand everything, we've already created this demo app for you and open source the code. So you can visit the app through the link below and also check out the source code. Let's try it out.
Rock, paper, scissors, shoot.
One more time.
Rock, paper, scissors, shoot.
Draw again. One more time.
Rock, paper, scissors, shoot.
See, isn't that fun? You feel free to try it out by yourself. Let's recap what we just talked about today. MediaPipe is simplifying on-device ML solutions with 3 new products. MediaPipe Tasks will help you deploy advanced on-device ML solutions across platforms. MediaPipe Model Maker will help you customize solutions using your own data. And MediaPipe Studio will help you customize and prototype on-device ML solutions without code. If you want to learn more about MediaPipe tasks, Model Maker, and Studio, try out our documentation at developer.google.com/MediaPipe. Subscribe to our newsletter at MediaPipe-solutions-external-announce. And always feel free to reach out to us at MediaPipe-solutions-team-support@google.com. Thank you for your attention. If you have more questions, I'd be happy to answer them now. So the first question I'm getting here is there a statistically significant difference in running time when using MediaPipe to deploy across different platforms? That's a good question. Right now, MediaPipe tasks support cross-platform support on Android, iOS, and web. And iOS is coming soon. You will notice a different performance on each of the platforms according to the configuration and accelerators you use specifically. In general, the Android support, we have put most of the effort to optimize it, but we're working hard to improve other platforms as well, for example, on web and iOS. For more updates on this, please visit our website and see more documentation on top of that. The second question I'm getting is, has the gesture recognizer been used in applications for translating sign language? Internally, we're working with some Google product teams to make that happen. And hopefully we're having some good news for the developers in 3P next year. So the short answer is yes. And if you are interested to build your own translating sign language app, feel free to try out and let us know if you have any problems or feedbacks. We'll be glad to optimize our support according to your requests or feedbacks. Any feedbacks will be greatly appreciated. The third question I'm getting here is, does this work for low constraint embedded devices? So MediaPipe tasks, right now, the Python API only works for desktop, but soon we're going to extend the support to support IoT devices like Raspberry Pi and Coral. If you're asking about embedded devices like a microcontroller, so far we don't have, this is not in our near future roadmap yet. But if you have a more concrete feedback or use cases, feel free to let us know. Now I see the fourth question. Does MediaPipe support in Flutter app development? So Flutter, being able to support Flutter development is in our radar. Currently, we don't have any active work stream on this work yet, but we're keeping in mind if we see strong intentions to support Flutter development, we'll be working on that very soon. Okay, so another question I'm getting here is, what are the other ML tasks that I can do with MediaPipe? So in this preview release, right now we support 5 tasks, including a bunch of vision tasks like image classification, object detection, and 1 NLP task like text classifier. We're actively adding more in 2023, and we aim to have more support around vision, text, and audio across those domains by the end of next year. So the next question I'm saying here is, will MediaPipe tasks support iOS? Yes, we're working on that, and hopefully it will be able to support it by mid of 2023 in the I/O release. So next question is, will Model Maker be available on languages other than Python? So we're working on a no-code model optimization customization feature in MediaPipe Studio. If you don't know Python, you can still train custom models using MediaPipe Studio in the near future. So hopefully, Python will not be the only option for you to customize your model. Again, feel free to visit our website at developer.google.com/MediaPipe for any updates and the latest status of us. And feel free to reach out to us at MediaPipe-solutions-team-support@google.com if you have any questions and feedbacks. Thanks a lot for your attention. And we're really excited about the coming quarters with all the new features. And we hope that you are the same. Stay tuned. Thank you.